flash comparator ADC, that is analog to digital output. So if you observe here, in the output they have given Y2, Y1, Y0. That is, you are getting the output in the form of digital format, right? So here you are getting the digital format. So where you will be applying the analog input voltage? So analog input voltage is applied to all the comparators. So as I have told in the previous video, okay. So the important terms that you are using in order to design or to construct the flash comparator is resistors, right? So these are all the resistors and the comparators. So these are all the comparators and again the encoder, okay, and again the encoder. So these are the three important terms required in order to construct the flash comparator ADC. Okay, now we will try to understand how this flash ADC will actually work. So as I have told you, I have written a small table, right? So if I have written one small table with respect to the comparator, so what is that table? So what is that table? If VA is greater than V reference, I think it is not visible if I am writing there. Anyway, I'll just explain it. Okay, I'll just explain it. So now, how this comparator will actually work? I have told with respect to one of the table in the previous video, right? If analog input voltage is greater than the reference voltage, then your output will be equal to 1, right? So I have explained the previous table. Okay. So if the quantity that whatever you are applying to the positive terminal is greater than the quantity that is coming to the negative terminal, then the output is considered as 1. In the same way, if the negative terminal is having the highest quantity than the positive terminal, then I can call that output as 0. One more case what I have told, if both the quantities are equal, then your output will be having the same previous value. So this one I have already explained by taking a small table. I will explain that later on. Okay, now I have to explain the diagram, right? Okay. So if you just observe how to write this diagram, I will just tell you. So first you have to write the 8 resistors. Okay, vertically you have to write the 8 resistors. Okay, and again the comparator should come between the 2 resistors. See here, one comparator comes between the 2 resistors. So 8 resistors vertically and 8 comparators vertically, and again the 8 comparators should come in between the 2 resistors. Okay, so if you just observe here, between the 2 resistor one comparator, between the 2 resistor one comparator, and between these two one comparator, like that. And the output of the comparator is represented as x7, 6, x5, x4, 3, 2, 1, 0. And now one more important thing, positive terminal. All the positive terminals are being shorted and it is given to analog input voltage. I repeat once again, all the positive terminals, if you see here, it has been provided with the analog input voltage. Okay, and for all the negative terminals, you are connected to this circuit which is having the number of resistors. So after one resistor, you have to take one point and you have to give to the negative terminal. After 2 resistors, you will be getting one more point and that is connected to the next comparator negative element. And after the 3 resistors, you will be getting one more point and that point should be connected to the negative terminal of the 3rd comparator, and it follows. Okay. Now, what is the voltage drop across this point? How to write that one? And how to write the voltage drop at this point? At this point, this. So I have written here. So this point is directly connected to ground. So therefore I am writing it as 0. And what is the voltage drop at this point? It is VR into 1 by 8. I can call it as VR by 8. So why it is divided by 8? Why not by 7 or 6 or 5? So if you just observe here, how many points are there? This is the VR. To the top point you have to give the VR, that is a reference voltage. So after here, how many resistors or how many points are there? 1, 2, 3, 4, 5, 6, 7, 8. So since this is an 8 point, I have to divide VR by 8. Okay, and next, so the 8, the denominator remains the same for all the potentials, but coming to the next point, this 2 VR by 8, next 3 VR by 8, 4 VR by 8, 5 VR by 8, 6 VR by 8 and 7 VR by 8. So I hope you have understood how to write this potential at each terminal. Okay, are you clear with writing the diagram? So I hope you have understood this part, this part. Coming to the priority encoder. So then I have already told you to construct this flash comparator, you require a priority encoder, and that priority encoder is 8:3. Why it is called 8:3? Because you are providing the 8 inputs, 1, 2, 3, 4, 5, 6, 7, 8. 8 inputs are there, and you are providing the 3 outputs. That's why it is 3. 8:3 outputs. Okay. So this is the construction part. Now we shall understand how actually this particular flash comparator will work. Okay. Listen carefully. It is very important to understand the concept. So now let me assume that my reference voltage is equals to 8 volts. Let me assume that my reference voltage is equals to 8 volts. Okay. So VR by 8. Under 8 by 8, you know, 1 volt, right? It is equals to 1 volt. Okay. Next, 2 VR by 8 means what? It is 2 volts. So now it is very simple. I am just substituting 8 volts. This is just an assumption. Okay. Assumption in order to understand the concept. Okay. So I am just substituting this 8 volts in the place of VR. So you will be getting it as 1 volt, 2 volt, here 3 volt, here 4 volt, here 5 volt, here 6 volt, here 7 volt, and here directly 8 volt. Okay. Now my analog input is equals to 1.5. My analog input is equals to, even this is also an assumption. Okay. Now what is the thing you have to do? You have to convert this analog input voltage to the digital output, right? I have to convert this analog output, that is 1.5, to digital output. So how this will work, we should understand. So my analog input voltage is equals to 1.5, right? So here you will be getting 1.5, here you will be getting 1.5, because I am shorting into all the positive terminals of the comparator. So here 1.5, 1.5, 1.5, 1.5. So like that I am providing 1.5 to all the positive terminals of the comparators. Now, so what is the second quantity that you are getting for this? What is the second quantity? That is, what is the voltage that you are providing to the negative terminal here? You are providing 0. So 1.5 is compared with 0. Which is greater? So positive terminal is greater. So therefore x naught you will be getting it as 1. Okay? I repeat once again. See, the negative terminal is connected to these points. I have already explained how you have got these points, right? So 1.5 is compared to 0 volts. Which is greater? 1.5 quantity is greater. If positive terminal is having the highest quantity, then your output will be 1. I have already explained with respect to the table, isn't it? Next. So what is the value here? 1 volt, right? At this point, I am talking about the second comparator. So the negative terminal value is 1 volt. We have already calculated what is the value that is coming from the negative terminals of each comparators just now. So 1.5 is compared to 1 volt. So 1.5 is only greater. 1.5 is only greater than 1 volt. So therefore even x1 is also 1. Next, coming down to the next third comparator. So here you will be getting it as 2 volts. Okay, here you are getting it as 2 volts. So 1.5 is less than 2 volts. So therefore the output that is coming from this comparator is equals to 0. So this will be equal to 0. Okay, next for this. So here you are getting 3 volts. So now again I am comparing 1.5 and 3. So negative terminal is more than the positive terminal. So this output is also 0. So likewise, if it is growing towards up, so once it comes 0, rest all will be obviously 0 itself. You can just try out by substituting these values here. So the rest of the values will be equal to 0. Okay. Now I will just explain this priority encoder with respect to the table. Okay. In the next video. I hope you have understood this flash comparator. I repeat once again. So the flash comparator consists of the resistors comparators and the priority encoder, and the analog input voltage is common to all the positive terminals of the comparator, and for the negative terminals you have already calculated here. Understood? Next I will be explaining by taking how this encoder will be encoding into the digital value. Okay, see here this is an analog input voltage. So now you have to develop the output voltage which is in the digital form, which is equivalent to this 1.5. You may not get exactly 1.5. Can you represent 1.5 in the digital form? No, you can either represent 1 or you can either represent as 2. In between you cannot represent. That is the disadvantage in the digital value representation. Okay, I hope you have understood. Now this 0 0 0 0 0 0 1 1 is given to the encoder. By taking these values to the encoder, what will be your output? We'll just understand by considering this table. Okay, explaining this table in the next video. Okay, copy down this whole diagram and assume that your analog input voltage is equal to 1.5 volts. Okay, 1.5 volts, and assume that your reference voltage is equal to 8 volts. So copy down the same thing whatever I explained. Okay, next I'll explain the table.